Okay, so today we're going to be talking about vectors in 3 dimensions. And before we get started, I want to make sure to revisit our calendar. So tonight's homework, there's actually 2 parts to the homework. The actual homework is this worksheet that I'm going to give you that's for review from sections 8.4 to 8.6. The reason for that is you have a quiz on Monday and Tuesday for second period. So this review worksheet note is due Monday or Tuesday, depending on your class. And then there's also packet problems that are not going to be due until Wednesday, Thursday. Monday, we're going to take our quiz. You will be allowed to use a calculator. And then there's a quick little handout on the cross product. And then there'll be just like some quick little problems as well. So both this homework here, the section 8.7, 658, and this homework here, 8.81, will both be due on Wednesday, Thursday. Okay, so today's focus is to talk then about vectors in 3 dimensions. Now that you understand how 3-dimensional space works, then let's talk about how we see vectors in 3 dimensions. So oftentimes, physical forces and velocities are not confined just to the plane. So it's natural to extend vectors from 2D into 3D space. And so we use ordered triples to represent the components of our vectors. So if we have an initial point, say x1, y1, z1, and a terminal point, x2, y2, z2, then we can represent the vector as x2 minus x1, y2 minus y1, and z2 minus z1. So given an initial point and a terminal point, you can just find each of the individual components of your 3D vector. Let's make sure to talk about some of the special vectors. The 0 vector is denoted by 0. It means 0, 0, 0. It's the origin of the 3 planes. And we have some unit vectors, the I, J, and K vectors now. So the I vector is the one that moves along the x-axis. It has a length of 1 and has no y or z. The J vector has a y coordinate, 0 for x, 0 for z. It has a length of 1. And the K vector, so this one is representing a length of 1 in the z direction. And so the standard unit vector notation, also known as aka IJK form, aka a linear combination. So depending on the text that you use, some books call the IJ form or IJK form a linear combination. We've been just calling it IJ form. So our form then would be v sub 1 I, v sub 2 j, and v sub 3 k. So a lot of what we talk about today is going to be just review, really. How do you work with these things in 3 dimensions? We're going to talk about magnitude, sum, difference, dot product, and so on. So let's say, for example, if we have vector v, which has components v1, v2, v3, and vector u, which has components u1, u2, u3. Then if I wanted to find the magnitude of, say, vector v, well, normally when we find the magnitude, we're just finding the length or the distance. And we talked about this last time. You can find the distance using the distance formula in 3 dimensions. And if I have my vector in component form, I'm just taking each of those components, I'm squaring them, adding them, and taking the root. The sum of any 2 vectors in 3 dimensions are going to be what you would expect. If I'm going to add 2 vectors together, then I'm adding their individual components. Bless you. Similarly with their difference, and as with any subtraction, the order matters. So if I'm going to take u minus v, then I'm going to take all the u components and minus all the v components. Scalar multiples works in what you would expect ways. So you take, let's say if c is a constant, then I take that constant times each of the individual components of the vector. You guys need tissues today. So sniffly. And lastly, the dot product. So you can find the dot product of two vectors in 3 dimensions. Any guess? u1, v1, u2, v2, and u3, v3. So how about an example? Find the component form and magnitude of the vector that has an initial point 3, 4, 2 and a terminal point 3, 6, 4. So first we want to figure out what this vector is. What's the first component of this vector? 0. What's the next component of this vector? 2. And why is it not negative 2? Yeah, we take 2 as well. Form, however you like to call it. You can call it so. Okay.